discussion. So first, I will introduce in short what is Neara and hello. Okay, so I'll introduce in short what is Neara, and then we'll see why Neara, what is difference between the Neara and the other software in the markets. Then we'll see the solutions that are offered by Neara, and then we will have overview of the parts of the Neara that are Neara Point Cloud, Neara Analytics, and Neara Designer. And then we will see what will be the outcome for the utilities after using our software. Then Mr. Mackenzie will show you the live demonstration of the software. And at last, we will have a question and answer session. So if you are having any question, you can drop them in the chat box and we will answer you at the end of the presentation. And yes, in between, if my voice is not clear to you or due to some internet issues, if my screen is lagging, then please do not hesitate to interrupt me. I will repeat that part again. So let's begin. So Neara is founded in 2016 as a Powerlines Pro, and our platform delivers a true digital twin performing complex engineering grade analysis automatically and at whole of network scale. So Neara, which is formerly Powerlines Pro, is a cloud-based enterprise platform making the most complex analysis, design, and application accessible at entry level of uh, accessible at every level of the infrastructure industry, and it is now been utilized by most of the utilities and engineers across the globe in just 4 years or 5 years of time span. And our mission is to empower organizations by bringing them closer to their asset, environment, and business through our intelligent software solutions. And we are proud to say that PI Engineering are an authorized distributor of this software in India. Now let's see why we should go with Neara. What are the key features of our software that makes it superior than the other designing software available in market? So about wide breadth of functionality. So we can say our digital twin solution covers a wide breadth of risk-based use cases, and with the help of them, we can identify, remediate, and reduce the risk across the network. About high fidelity and engineering grade 3D models. So it conducts advanced analysis with ease both at an individual asset level as well as at an whole of network level. And the secure cloud-based fully editable 3D digital twin model of the network assets, acting as a unified platform for network design, planning, and management, usable for both clients in-house team as well as for usable for or usable for contractors. So both of them can use it, and we can start it or we can start the designing right away on the platform. And the use cases, as I told before, can deliver business value within the weeks of digital twin completion. And Neara has capability to model both transmission and distribution assets, and it enables to have visibility and unlock use cases across our entire network. So here we can see how Neara's advanced digital twin differs from the other similar software offerings. And before starting this slide, I would like to first inform about what is digital twin. So many of the professor here may be knowing, but if there are some students watching after this, after means student watching this recording, for them, I would like to just tell in short what is digital twin. So in simple words, digital twin is a replica of any living or non-living things. By connecting physical or real world and virtual world, we can transmit the data completely by allowing virtual entity to exist simultaneously with the physical entity. Or we can say modeling a physical world virtually is simply a digital twin. And it helps to run industries better and to operate and maintain all complex machines. So it is fascinating and important area for wide range of stakeholders and industries. Now coming towards this slide, as you can see about the data processing or classification. In other offerings, it is semi-automated and requires to do more tasks manually, many of tasks manually. So it is little bit time consuming and can be inaccurate. And in case of Neara, it is fully auto processing and auto classification is having approximately 99% accuracy, and we can do 30 times faster. We can do it with 30 times faster speed. So it is a quick process as well as much more accurate. In case of data visualization, analytics, and interpretation, our digital twin are using non-engineering grade 3D non-engineering grade model with 3D GIS based visualization of asset and vegetation, as well as their digital twin has capability to perform detailed asset level analysis, but it is unable to perform network level analysis at speed. But in case of Neara, it is cloud-based, scalable, editable 3D network-wide digital twin with fully functioning engineering-grade model operating on a physics-based design platform, and it conducts various detailed analysis, as you can see on the screen, like pole deflection or conductor blowout simulation, pole cascading failure, pole and tower loading risk, and other for entire network with an ease. And last, talking about outputs and integration. So other software have limited data sources like geospatial or 3D images, and many of time by it is usable just for one team. Maybe you can say the team which is sitting in office can use it, or the teams which is on the field can use it. Both of the teams cannot use it simultaneously, or we can say we cannot use it concurrently. But in Neara, it is unified platform that allows multiple data sources, including satellite images, GIS, inspection photos, LiDAR technologies. Now, LiDAR technology, which is stands for light detection and ranging, and in this we use laser lights to measure ranges or variable distances on the Earth's surface. And along with that, we can use asset libraries also and engineering standards, which can which can be used by both teams in the office as well as the teams which is out of the office, or we can say on the field. So both the teams can use it concurrently. Now, here you can see the process that how it works or how Neara works in the project life cycle. So as I told earlier, Neara is a cloud-based enterprise platform which delivers significant cost savings, efficiency improvement, safety enhancement, and risk mitigation across the customer's network. And in first step, as you can see here, we just first take input from the utilities input data. It might be from GIS, that is or images or their asset libraries or their previous CAD drawings, and the other input data. So we can take input data, then we process this data and produce 3D engineering grade digital twin for both distribution assets as well as for transmission assets. So after producing this digital twin, with the help of this digital twin, the utility can able to unlock multiple use cases such as network planning and analysis, vegetation management. We will see it later in our demo, or I will explain it later in my slides, or clearances analysis or weather simulation, that will also we will see later. So we can use such use cases and can deliver business value to the utility after completion of this digital twin. So here are the value proposition or the promises that we offers to the utilities. The Neara platforms deliver true digital twin, performing complex engineering grade analysis automatically for both at an asset level or at whole of network scale. So you can see here it is for single asset level, and here the third image you can see it is for whole of network scale. So we can uh, do analytics for both of these cases. And throughout the process, while maintaining the accuracy, we are also successful in order to manage the project timelines. So it is accurate as well as it is less time consuming. So now, as you can see in the screen, there are the situations which occurred by nature or naturally occurring problems, we can say here. And we have capability to de-risk these weather related impact. So as you can see on the screen, on the first image you can see the wildfire management. If my I hope my screen is very clear, and you can see here some yellow dots which are for means which are showing the fire taking place. So in this case we can see where is the fire taking place or where it can be approached, and restore the uh, we can we can have real monitoring of these things, and we can restore the power supplies, or we can prevent the damage to the asset which are at risk. Then in the middle image you can see the swings happening uh, due to the storms or high winds. So at that time, there is a risk that power lines can swing and can touch to the nearest trees or some conducting parts, and it can cause fire also as well as it can damage. And many of times they can touch each other also, so it can damage themselves. So in this case, we enabled our client to predict and systematically identify and mitigate at-risk spans, so that specific area where the span is large can swing more. So we can reduce that span, and we can prevent damage or the other danger that can be happen. And in last image, you can see the flood analysis and response. So all these yellow thing you are seeing here, it is water cause coming on the ground in case of floods. So most of the time, this case occurs at rural sites or at the cities which are based on the river banks. And whenever any of these situation occurs, we know what will happen first. The first power supply failure we can face, or simply they will cut the power supply for uh, um, for uncertain time until all the situation get clear and they restore the things. So in the case of floods, we help utilities to produce network damage analysis or reporting in the middle of the flood emergency, and we can start our process within 48 hours of flood commencing, and enabling faster restoration of the power supply in that region. Our platform, now we can see here three parts of Neara. So we can say Neara is classified into three parts. Uh, the first one is Neara Point Cloud, Neara Analytics, and Neara Designer. So coming towards the Neara Point Cloud, first let's see what is point cloud. I'll tell you in short. So point cloud is set of data points in space. It can be produced by 3D scanners, which measures many points on external surface of project. Okay, I will repeat this. So point cloud is set of data points in space, and it can be produced by 3D scanners, which measures many points on external surface of all the objects around them. And it can be used for many processes like to create 3D CAD models, or for metrology or quality inspection, or for a multitude of visualization, animation, and mass customization applications. Neara Point Cloud is purpose built for utilities, so it is a specific to simplify and streamline all stages of geospatial data. You can see here in the first image the purple line, which is showing the transmission lines or distribution lines here. The red one is houses, and the green one is trees, So we can see all these things here, what Neara point cloud can do. So Neara point cloud perform automatically generates an engineering 3D engineering grade physics enabled a digital twin from point cloud, LiDAR, and asset information. And these powerful models can be used with Neara point cloud to deliver efficient data combination or data integration and from multiple sources. Then it can deliver accurate point cloud classification and processing at scale. Also, it enhanced vegetation and asset management delivery. Now coming towards the Neara Analytics. So Neara Analytics is a network-wide, fully customizable analytics and reporting platform. And at center of this Neara Analytics is the physical network digital twin, which is auto-generated from existing data, including GIS, LiDAR, images, maps, tables, and other records. As the real network changes, the digital twin remains up to date via various data capture or direct model editing within the Neara Analytics and Designer. So, if there are any changes in network, it will directly get up to date. So we do not have to do anything manually. And as it is cloud-based software solution, the sharing, collaborating on workflows, reports, and dashboards is effortless. Users on any computer can leverage same analytical tools and insights. Now coming towards the last part of these modules, that is Neara Designer. And Neara Designer can create cloud-based engineering grade 3D models by leveraging existing data, and it enhances our design process by increasing our speed as well as efficiency. And integration with Neara Analytics unites individual design output with whole of network scale. And it is simple as well as multi-format data export. Let's Neara Designer comfortably integrate with a larger software ecosystem. So anything complex we can have, it becomes simple with Neara software. And as I told before, as it is a cloud-based software, teams can share, collaborate, and iterate on designs efficiently. The same design functionality can be accessed and leveraged anywhere. Now on screen, you can see some case studies. So first, in this case, we speed up the risk identification by 10 times for one of the large utility. The challenges for that utility are as you can see on the screen. So that utility has to, or our client was first has to do field visit to inspect each pole, so that that process was little bit time consuming, and it was also unscalable. Also, the analysis can be done by this was very basic, and also they need to have additional engineering resources for loading determination. And what Neara offers them, that we uh, that we can produce a network, or we give them a network digital twin and extract and model and analyze scenarios to their networks. And because of that, that utility achieved from this is as follows, that they their outcome was a scalable solution for pole asset assessment, enabling utility to make prediction on assets to be replaced, or improving OPEX, that is operational expenditure, and sustainability of the pole fleet. In second case, we can see we improved data classification speed more than 30 times for one of the geospatial firm. The problems faced by a client were their existing point cloud data processing software was inaccurate and inefficient, and thus client had to do most of the task manually, more than 80% of the task, or more than 80% of the things from their point cloud data set they have to do correct it manually. And Neara Point Cloud introduces advanced techniques to detect patterns and extract features automatically at scale, and thus the client achieved 98%, approximate 98% classification accuracy, and accelerate their classification or processing speed by 30 times, which helps them enhancing the scale of their business process. Now we can see how we can enable host of use cases to deliver business value to utilities. You can see some of the use cases here, like data processing or classification or designing or vegetation management or pole and tower maintenance. So we can see in short one by one. In case of data processing and classification, so automatically denoise raw LiDAR data we can do, and automatically classify data into the features or objects, and it helps to improve processing speed up to, we can say, 30 times than the other conventional software, and accuracy we can improve to approximate 99%, which ensures clean data input into your digital twin. As we are using LiDAR and GIS, so we get correct asset location and asset property. Also, we can conduct structural rating and feasibility studies on existing and new assets. It helps to improve visibility and intelligence on asset location and condition across the entire network on the single platform. In case of design, as I'm saying from starting, we can have auto-generated digital twin model. So using so which can use your existing data, that is from LiDAR or GIS or etc. other. It can also perform network planning and asset design or quality assurance all on the single platform. And we can export the design and analysis into multiple formats such as CAD or CSV and etc. And as I told earlier, it is a cloud-based software, so it enables seamless collaboration on design or reports across the team. Thus, we can share and collaborate designs and output across our team as well as with our contractors. Now coming towards the vegetation management. So vegetation management is one of the important factor while designing the transmission and distribution lines. Using Neara, we can identify conductance clearance uh, against vegetation or other assets such as conducting parts on the maps like roads or buildings or any living parts. So any living or non-living parts, obvious. So by using automatic tree segmentation, LiDAR vegetation data layers into individual trees, so we can enable tree growth, and we can enable tree growth, we can record it, and we can analyze it over the time. It supports vegetation management compliance requirements, and also enables optimization of vegetation of and also enables optimization of vegetation cutting and inspection frequency, and also reduces this the spend on it. Like this, we can also do predictive pole and tower maintenance, as we have visibility of each of our pole, tower, or conductor fleet age and conditions. We can auto calculate pole structural integrity and also calculate asset degradation profile of our poles or conduct or any other conductors and towers. And we can perform cascading pole failure analysis to simulate damage of a failure on adjacent assets. And because of this, we can optimize pole maintenance and inspection spend. And last but not least, that is the risk management. So, so overlay network with bush fire risk data, or like we see in our previous slides for wildfire management, or storms, or high winds or flood management. So we can predict the risk, and we can prevent the damage by securing the assets at the risk stage. Now in this slide, we can see how the piloting with Neara could look like, or the approximate time requirement for each process, and finally we will see the outcome for the companies. So first step, as you can see on the screen, understanding and agree on the scope and obtain data. So first we will determine the region and use cases scope for piloting. So as we have seen earlier, first we'll see their use cases, and we can see what are the improvements to be done. And this process will take approximate 1 month. Then in second stage, we build a digital twin. At this stage, we ingest and process the data and build 3D digital twin on our platform, and also review and refine digital twin with additional data wherever needed. And again, this process will also take approximate 1 month. And in last step, we build and deliver the use cases. So in this, we customize analytics and analytics engine and reports and dashboards based on agreed use cases. And we deliver pilot use cases such as vegetation management, like we seen earlier, or wildfire analysis, or storm in simulations. And this process will take approximate 2 months. So if you could see here, the overall process will take only 4 to 5 months approximately to take input, to process, and to form digital twin, and to deliver all these things. And now we'll see the outcome for the utilities. We'll get accurate 3D digital twin of our network on single platform with flexibility to edit asset location or properties, and expand to add your whole network. Then we accelerate the identification and mitigation of weather related risk. So means our speed to this risk management is increased, and we will have data driven approach toward the grid hardening, and and ultimately we will have more efficient network planning, cost saving, and also reduction in time requirements throughout the projects. Now, that's it from my side, and I'd like to hand over this presentation to Mr. Mackenzie, and he will show the live demonstration of Neara software. So, Mackenzie, can you take charge?
Yeah, thank you very much, Aperv, for the introduction and great presentation to take us off. So everybody, as he mentioned, I'm going to take through exactly what it would look like in the if you were to use a product for yourself to dive down into different network reports and basically just take a deep dive into the network. So you should see my screen come through in a second. Let me know when that's come through. Yeah, so that looks like it's all sorted now. So what we can see here is an example of a New Zealand utilities network. So if I zoom out here, you can see that we have, in a very easy to view fashion, their entire network on the map. If I go over here to our different reporting functionalities, what I have here is a violations report for their entire network. So just to explain this very briefly, these different color codes are different violation zones between either poles and conductors or vegetation. A1 is the worst, and I think from memory it's about 5 centimeters of clearance, and then these zones increase in radius out to where they determine that it's clear. So you can see here that I have a very nice overview of my network and some information about where each of these is located. So from here, we can determine that there's going to be some sections that immediately need triaging. So for example, it's looking like this one here is going to be our worst affected section. So if we dive into this, we can see that this is a similar version of the report, but as I start to move into different areas, you'll see that this report will start to update. And so as I continue to move in, this will continue to update so that I'm getting the most true information of the area of the network that I'm looking at, until we've dove all the way into a specific area. And now you can see that in the small region here, these are all the issues that are occurring. On our map here, you can see exactly where the network is located. And if I just filter this to make it a bit clearer, then we can see that this is our network model. So these are going to be all locations of our poles and our conductors. This report here is basically just showing in more detail what's being shown on the side here. So we have some information on the distances between the vegetation and the conductors and the associated risk. I won't bore you with all the details of it. If anyone's interested, we can dive into that afterwards maybe. But this is basically just giving an overall view of what the area will look like. And once again, as I zoom in or out, you'll see that the number will change. And so this allows me to look into a specific section and to determine exactly what the worst affected risks there are. This report here is, whoops, sorry, that's the wrong one. This one here. So say, for example, we want to look at this section here. I can go ahead and load it directly from the map, which I've already done just for the sake of speed. And we can now see that we have a workable version of our network model that we can interact with. We can move around the different conductor spans. We can place or add or remove. What I have here is these circles on the ground dictate our GIS points. So this is where the network thinks that their poles are located. And with this, the pole locations here are derived directly from the LiDAR. So if I go ahead and turn up our, on the right here, I have also a view of all of the data sets that are contained within my design so that I can go ahead and edit or remove them as required. If we now look back over here, we can see that the LiDAR points are showing where the poles actually are located. So immediately, one of the use cases we can derive from this is to determine how far away our pole locations actually are from where the utilities think that they are. And this is something that a lot of people have issues with actually knowing where their assets are. If I want to dive into here a little bit further, I can then go and start to do some asset analysis. So for example, I can go ahead and run either create reports just for this area as well, which I can visualize to know exactly where those violation clearances occurred. So for example, going back to this report here, if I want to look at the worst ones, which is going to be this A1 clearance here, I can go ahead and turn on the violation zone here and filter to only show A1. Now I'll see on my report here that there's going to be 2 violation zones of A1. And if I go ahead and visualize this, you can see that they're going to be here and here. So we know immediately that these 2 spans need to be changed. It's a very simple process to go ahead and do this. We can simply just move the location of the pole until it's no longer violating. And you'll see that as I move it, the LiDAR will start to be colored as well. And so this is showing where the blowout risk for this conductor span is. So this is telling me that I might either need to remove this vegetation completely or try and find an optimum configuration whereby this will violate the least amount. This can be done for every span. It can be changed in a similar manner. If I wanted to go ahead and determine the strength of each of my conductor spans, for example, I can go ahead and run finite element analysis. And so what this is doing is taking the environmental the environments that we've set up for our design in this tab here. You can see the different information with regards to pressure, ice, snow, etc. You can go ahead and run this against 8 different angles, against 360-degree angles, sorry, and simulate it. So I've gone ahead and simulated it for us already, and you can see that we now have a variety of different values on here. And what this is telling us is that our pole right now is overloaded, and we can tell from visualizing it that we can see that that pole is in fact going to be breaking under the loads that are being exerted from this pressure. So we know that this might need to be changed. If I wanted to go one step further into the vegetation analysis and go to a different area of my network that has more detailed vegetation, so for example over here, I can go ahead and visualize once again those clearance zones alongside the conductor span. So similarly to before, we have our different violation zones. We can go through and we can edit this report to show exactly what we want it to be showing, or to change the value of different information. But what I want to draw your attention to is the fact that we can see in real time how our conductor span will be, how vegetation will cause issues on our conductor span. So you can see from here that with the different color coding, there's going to be several different regions of violations. And so you might be thinking, this vegetation up here is very far away from the conductor. Why is it being shown as an error? What it's showing is that if these trees were to collapse towards the line, this would be how much would need to be removed in order for them to not touch the line under any environmental conditions. So we're able to visualize it based on what the client's requirements are. For this one, it was a 45-degree from the angle from the conductor span, as you can see. But this can be changed depending on what the individual needs are. What I have here in this plan view is the kind of top-down perspective to visualize much more easily, the blowout of our conductor spans. So you can see that what I was showing over here is being shown here again. And from this perspective, it's very easy to see that these immediate zones over here, are going to be causing some tremendous issues. And if I go ahead and simulate the blowout of this line, you can see exactly where that's why that's being shown. Let me just make this a bit clearer, Yeah, so now it should be quite obvious. Hopefully you can see that. I'm not sure how well it's being transmitted, but you can see that our conductor span is now going directly into the vegetation, and that's why it's causing it to be this black and orange zone, because it's telling us that that is going to be the absolute worst clearance. And as it is right now, it's already touching the vegetation, which, as a perv mentioned earlier, can cause potential issues for wildfires or just network failure as a whole. Similarly to before, I can go ahead and simulate our finite element analysis on it. And so if I turn off the blowout, we can now see exactly how this span is going to be moving under different wind conditions. And so this is helpful to determine exactly under which angle of wind is going to be causing the most issues for our line. So we can see here that from 180 degrees angle based off of the line, so from this direction, it's going to be causing obviously our maximum blowout, but that under this situation, we're going to be going directly in to the vegetation itself. And so you might be wondering, like, okay, well, this seems pretty cool, but what are the actual benefits of it? Well, if we go back to our network-wide dashboards from here, these dashboards are basically showing exactly what I've simulated here. And so we can now see that if we go through here and filter on our fall-in risk zones, so for example, our maximum fall-in risks, we can see that in areas where there's many trees that are actually going to cause potential conductor failure, these areas are obviously going to need to be prioritized when it comes to looking over the conductor span as a whole. So that's just a very brief demo of what can be done with regards to vegetation and grid hardening. And once again, from here, the process of then determining what changes need to be made is very simple. As I said before, we can go ahead and export these reports into different different formats depending on what the data contained is within. For this one, because it's just a table, it's going to be CSV. But if I go ahead and if I wanted to export the different LiDAR from this, I could do that. All of these different things are possible. I'm also able to go ahead and export. I'm also able to go ahead and visualize, sorry, our profile view. So this once again is just adding another layer of kind of user friendliness to it. You can very easily see through here where there are going to be issues along the line. So I think that's probably going to be it from me. I wanted to just keep it simple just so that I didn't want to overload you guys with too much information. Yeah, so thank you very much for listening to that. Apurv, do we want to move into any questions or anything now?
Yep. First of all, thank you so much, Mackenzie, for the demonstration. I guess so far there are no questions in the chat box, but I would request the joiners to, I mean, you can unmute yourself to ask any questions if you have.
Pooja, Pooja, Pooja. Hello, hello.
We can hear you, sir.
Can you hear me?
Yes,
Yes.
we can.
You can hear me. You see, actually, I was also in the power utility for 35 years, and
Oh,
I have worked in the transmission segment of the power sector. And when I've gone through this software and the parameters and the considerations, really it is a very useful for the utilities as well as for the teaching and for learning processes and all that thing. The main point in the transmission designing is the value difficulties. There are many problems for the compensation of the visitations, then the land which is being acquired, the corridors which are being involved in that. So how that is optimized and how the better compensation is possible by using your software. I want to get it from Mr. McKenzie's what he can add in that.
Yes. So just so that I understand your question exactly, are you referring to compensation based on actually acquiring the land or compensation of having to make these changes?
Yeah.
Oh,
The
which
compensation is the visitation compensation as well as the land compensation, because at the many times you have to erect the lines, or you have to erect the supports in
yeah.
such a dense area where the cost of the land is going in say 10,000 or 20,000 per square feet, say at the places where say in the high density areas, metro cities and all that. So how you are I mean compensating that, and how you are taking into consideration while designing and construction.
Yeah. So what we're able to do with this is we're able to basically try and optimize the line that's being placed down. So obviously in very expensive land, you want to minimize not only the amount of land you want to purchase, but also the amount of changes that will need to be made to the land as well. And so in a similar fashion to what I've shown here, you're able to take a scan of the location, whether that be LiDAR, whether that be survey points, whatever information it may be. And you can go ahead and place a series of different lines along through that to determine which manner is going to depending on your requirements, is going to either A, require the least change to be made, whether that be to vegetation, or to just be the shortest route possible to go from point A to point B in order to ensure that the costs to the utility are minimized. So in that fashion, because of through the ability to analyze pole tip loads and conductor braking loads, you can determine how you can basically optimize the line itself. So we have many users who've looked at us, and before using our software, they may have thought that a network required, say, 100 transmission towers to get from point A to B. And by the end of finishing using our software, they've been able to cut that down to, say, 85 or 90. And so those 10 to 15 towers not only represent a cost saving in terms of actual tower costs, but also they were able to determine more optimal routes than what they first thought. That meant that they had to make a lot less changes to the surrounding vegetation.
Thank you so much. Another question is that now we are very much interested in how to optimize the mass of the transmission line and the space of the transmission line.
Yep. So
I mean the design, the quantum of the tower material, steel material, how you can minimize that and how you can design that.
Yeah. So with regards to the transmission towers right now, that's something that we're currently in the process of building out in terms of actually being able to construct the lattices yourself. But the process of that will be a similar process to what we've done with just our single poles here, in that once it's built, you'll be able to run, the different tip load calculations for the tower and see whether it is much stronger than what you need, whether it's too weak, and try and create the optimum tower for each situation.
Okay. Thank you so much, sir. Thank you so much for giving a valuable input and all that.
No, that's my pleasure.
So, any more questions? Students, I hope you must have some questions to ask.
You can ask, or you can even put it in the chat box. I'll just ask it out.
पूजा तुझं झाल्यानंतर जे आहे ना शेवटी बोलताना मला हे कर.
Mackenzie.
Yes.
This is hi. How are you going? This is Bobby here.
I'm good. How are you?
Good, mate. Good. Look, while we have got few more minutes, like 7 minutes, do you have got that project you normally show how you put a pole on a Google map?
Yes.
That will be quite interesting for the students. If you can show that, please. Yeah.
Let me go ahead and show that.
Yep, please.
So if I go here just to our basic software program, in the situation where we have no information whatsoever, I can go ahead and just open up a completely blank design here. So ignoring this information here, go ahead and close this panel. I can now go ahead and you can see that I have zero information on this line whatsoever. If I go over to our map here, I'll just go to a location in Australia. So if I go to Sydney, you can now see that, let me turn this off, sorry. So what I'm going to do is just take a location here and bring it into the map. This is what we're starting with. If I go ahead and, sorry, just give me 2 seconds. Now you can see that I have the information contained from within our map overlay that we chose. So now what I can do is I'm able to design alongside exactly what is being shown on the map. Obviously, this isn't very useful because it's just a 2D set of information. And we want to go ahead and actually bring in some survey points. So what we are going to do is now go ahead and place a series of ground points like so. And what this is going to enable us is to actually bring in topographical data from Google Earth. So I'll go ahead and import this elevation. And now you can see that we have a base kind of topographic plane in order to work from. If I go ahead and do that one more time, just so you can see exactly what happened again. We'll go to another area here. So I'll go and place a series of these points. You can see that we're starting off with just a flat race section. If I now go ahead and import this survey information, now you can see that once again, our contours are being added through. We can then go ahead and place our different conductor span. Oops, sorry, let me make it a bit more realistic so it's along the road. We'll just go back over here. So now you can see that I'm able to design with the correct kind of topographic information available. And if I now go ahead to our, let me bring up our profile view, you can see that I'm designing with that. Mr. Shastri, this kind of is a much simpler answer to your original question with regards to optimization, because you can see that if I turn on, I hope I pronounced your name correctly. I'm sorry if I didn't. But you can see that now looking at these poles here, they're very clearly able to take the load that I've placed upon them. So I can assume that I'm able to go ahead and delete some in order for them to still be able to take through the load. And in fact, that was correct. You can see that I've been able to minimize the amount of poles from 6 to 4, and I can get the real-time tip load information whilst I make those changes. So this is how it would work for the transmission towers once that section has been built out. But to explain what Bobby had asked me just briefly, if we were to make a very simple distribution design like this, you now see that we've been able to place our poles on correct topographic information. And we can now go ahead and derive all of our required reports, run different tip load analysis, different sag analysis, all of those things.
Yeah.
Yep. Is there anything else you wanted me to show, Bobby?
Oh no, that's all, Mackenzie. Thank you very much.
No, that's my pleasure.
So I guess there is no more question, Pooja.
No, we don't have any questions in the chat box.
All right.
Shastri sir would like to say a couple of words.
No problem.
Yes, Shastri sir.
On behalf of Shreyash College of Engineering and Technology, I am greatly thankful to today's presenter, Mr. McKenzie, and he has given a lot of inputs for the better design, construction, erection, commissioning, and all the things of the transmission line. And also, I, with great respect, mention that Durgeshan sir is really, by all means, he is guiding us, he is mentoring us, he is connecting us with the latest developments of the power sector in a different segments of the power sector, that is the transmission, distribution, utilization, and many of the things. And really, we are empowered with the help and the inputs which he has given and going to give, because since last 1.5 months we are in a series connected every Thursday, and actually this is nothing but a festival for us. It is a festival, great festival for the power sector people, the students, to get such a knowledge and the way, the thought process, the direction and the paradigm what they are giving us. We are really blessed and we are really impressed, and we will make the use of this in our institution by adopting your softwares, and the today's software which is presented by Mr. Purva and Mackenzie. I will give a thought and I will see that my management will approve this, because this is the need of the time in India now, to go with the software design rather than going with the trial and error, walk down survey and all that, because the parameters which the power sectors are at present adopting are not taking care the minute things, the micro detailing and all these things which will really add to the economy of the country, which will reduce the burden and which will add the developmental parameters of the nation, and it will help for the better service of the consumers, the stakeholders and everybody connected, because without power nobody can survive. With this, I again thankful for the contribution, the presentations, the contribution which the Durgeshan sir is giving to us. With a simple request, he has given his valuable, very, very valuable time to us and shared with us. For that, once again, I thank you. Thank you to Mackenzie, Apua, and Durgeshan sir. Okay, thank you.
Thank you very much for your very kind words, Mr. Shastri.
Yep.
I very much appreciate it.
Thank you. Thank you for your kind words.
Thank you all. Thank you so much. The feedback link has been shared in the chat box. Kindly fill the feedback form for your certificates.
Okay. Thank you then. Bye-bye.
Okay. Thank you, Mackenzie.
Thank
Sure,
you.
bye.
Thank you very
so
much,
much.
everybody. Goodbye.
Yeah.
Bye-bye.
Goodbye.
Bye bye. Bye bye. Bye.